this sine B sine A by 2 instead of this and this, sine B A by 2 and minus C by 2, and again sine A, this will be C by 2 minus B by 2, and your sine C, this will be sine C, sine C, this will be B by 2 minus A by 2. So now uh, here this will be, if I am going to apply this um, sine B. Now if I am going to apply the sine rule, A by sine A is equal to B by sine B is equal to C by sine C is equal to K. So here instead of A, I can write that is K sine A minus K sine C by 2, and plus sine A, instead of the C, uh, I can write this is K sine C minus K sine B by 2, and this will be sine C, this will be K sine B minus K sine A by 2. So here now, if I take k by 2 common, if I took k by 2 common, so this will be sine B sine A minus sine B sine C, and then sine A sine C, and here sine A uh, sine B, and then sine C sine B minus sine C sine A. So here you see sine C sine A, this cancels out, sine A sine B, this cancels out, all this cancels out, so k by 2 into 0, this will be 0, this is right hand side, this is your proof. So now I am going to question number, I am going to question number your 5, question number 5, I am going to question number 5, question number 5. That is question number 5. In triangle, in triangle ABC, we have to prove that a square sine b minus c by sine b plus sine c, again b square sine c minus a by sine c plus sine a, and again c square sine a minus b by sine a plus sine b, this is equal to 0. So let me make some arrangement, that is sine b minus c by sine b plus sine c. Here by the help of sine rule, by the help of sine rule, I can find out the value of a. This will become k square sine square a sine b minus c by sine b plus sine c. So this will be uh, k square sine a into sine a into sine b minus c by sine b plus sine c. So this will be here. This again I can write as k square sine A, that will be sine A, and sine A, this will be sine B plus C, and sine B minus C by sine B plus sine C. And now again here uh, here there is a calculation. You have to show the calculation, that is mm, calculation is there is a the calculation. I have to show the calculation. For this I have to show a calculation, that is I have to show a calculation, that is sine, your sine b plus c is equal to sine b into cos c plus cos b into sine c. This is sine b plus c, and your sine b minus c, this is sine b into cos c minus cos b into sine c. So here sine b plus c into sine b minus c, this will be equal to sine b cos c the whole square minus cos b into cos b into sine c the whole square. So this will be sine square b, and cos square b I can write as 1 minus sine square c, and this cos square b mm, cos square b I can write as 1 minus sine square b into sine square c. So this will be sine square b minus sine square b into sine square c minus sine square c plus sine square c into sine square b. This cancels out, so this will be sine square b minus sine square c. So uh, this I can write as sine b plus, sorry, this I can write as sine b plus sine c into sine b minus sine c. This I can write as like this. So here you see the value of this, the value of this is this. So here k square sine a and sine a sine b plus sine c into sine b minus sine c by, this is sine b plus sine c. So this cancels out, and your answer is k square sine a sine b minus sine c. This is the conclusion I get. So similarly your b square sine c minus a by sine c plus sine a, this will be k square sine b sine c minus sine a, and your c square sine c minus c square uh, b square and your c square is, sorry, a minus b, that is a minus b by your sine A plus sine B. This can be written as k square sine C, k square sine C, uh, sine A minus sine B. So if I take this left hand side, so this value can be written as this value. This will be k square sine A sine B minus sine C, and this value is written as like this: k square sine B sine C minus sine A, and your this value can be written as k square sine C, sine A minus sine B. If you take k square common, so this will be, say, sine A sine B minus sine A sine C, plus sine B sine C minus sine B sine A, and then again sine C sine A minus sine C sine B. So here you find that this and sine A, this cancels out this, and this cancels out this, and so this is 0 into 0 is equal to 0, the right hand side. So this is question number 5. Now question number 6. In a triangle ABC, prove that is b square plus c square minus a square, your tan A will be c square plus a square minus b square tan B is equal to a square plus b square plus c square, your tan C. So now here I am going to use the formula, that is cosine formula, that is a square is equal to b square plus c square minus 2bc cos A, and your b square is equal to c square plus a square minus 2ca cos B, and your c square is equal to a square plus b square minus 2ab cos C. I am going to use this cosine formula. So from this will be equal to b square plus c square minus a square 2. That means this will be 2bc cos 2bc cos A tan A. So this will be equal to 2bc cos A, this is sine A by cos A, so this will be equal to 2bc sine uh, sine A. So this will be 2abc sine A by E. So this will be 2 sine A. So again for this will be 2 ca cos B tan B, and this will be 2 ca cos B sin B by cos B. So this will be 2 ca sin B. So this will be 2abc sine b by b, and here again this will be 2ab cos c tan c, and this will be 2ab cos c sin c by cos c. So this will be 2ab sin c, so this will be abc sin c by c. And we know that from sine law, that is sine a by a is equal to sine b by b. This is equal to sine c by c. So these three all are equal from sine formula. So these three all are equal. Now I am going to question number 7. Your question number 7. Here you see question number 7. Question number 7. That is b square minus c square cot a plus c square minus a square cot b plus a square minus b square cot c. So left hand side, that is b square minus c square, instead of cot a I am going to write as cos a by sine a, and c square minus a square, instead of cot b cos b by sine b, and a square minus b square cot c, that is cos c by sine c. Now I am going to place the value of this. Cos a, this will be b square cos a value, this will be b square plus c square minus a square by cos a, that means by 2bc, and your sine a value will be sine a value from the sine law, it will be ak, so this will be ak. And similarly here your c square minus a square, your cos b formula, from cosine formula we are going to get, that is c square plus a square minus b square by 2ca, and your sine b will be equal to bk, and here again a square minus b square, your cos c formula will be a square plus b square plus c square, a square plus b square minus c square by 2ab, and your this sin c will be equal to ck. So here you see that your LCM is 2abck. So now if I multiply this, uh, let me multiply like this. um, uh, b square minus c square, b square plus a square, and then minus a square b square minus c square. So similarly your c square minus a square, your c square plus a square, and minus b square c square minus a square, and here again your uh, a square minus b square, a square plus b square, and here minus c square, a square minus b square, this. Now if you solve this you will get 0. If you solve this you are going to get 0. So this is equal to 0, you have to prove. So this is right hand side. So this is question number 7. Now I am going to question number 8. Now I am going to question number 8. Question number 8. here question number 8. This is question number 8. Here this is uh, mm, b square minus c square by a square sine 2a plus c square minus a square by b square sine 2b plus a square minus b square by c square sine 2c is equal to 0. So here I am going to left hand side minus c square by a square. This sine 2a, its formula is 2 sine a cos a. Again c square minus a square by b square sine 2b, 2 sine b cos b, and this a square minus b square by c square, this is 2 sine c cos c. I'm going to take both this formula, cosine formula and this sine formula. So if I'm going to take both this, a square by a square, so sine will be, this is into 2ak, and cos will be b square plus c square minus a square by 2bc. Similarly here, this will be uh, hmm, similar, this will be c square minus a square by b square. For sine b it will be 2bk, and for cosine this will be c square plus a square minus b square by 2ca, and then again a square minus b square by c square, this will be 2ck, and this will be a square plus b square minus c square by 2ab. So ultimately you are going to get this b square, this will be b square minus c square, and this will be b square plus c square minus a square by your abc, and this will be c square minus a square k, c square plus a square minus b square by abc, and this will be again b square a square minus b square, that is wait, I didn't wrote, that is k into a square minus b square, and this is a square plus b square minus c square by abc. So if you solve it you will get the answer 0. This is equal to right hand side. So this is question number 8. Now I am going to question number 9. Question number 9. Question number 9. Question number 9. That is question number 9. In triangle ABC, you have to prove that c square is equal to a minus b the whole square cos square c by 2 plus here, that is a plus b the whole square sine square c by 2. So your right hand side, that is a minus b the whole square cos square c by 2 plus a plus b the whole square sine square c by 2. So if you expand it, this will be a square minus 2ab plus b square cos square c by 2, and this will be a square plus 2ab plus b square sine square c by 2. So If you expand it here, a square cos square c by 2 minus 2ab cos square c by 2 plus b square cos square c by 2 and your a square sine square c by 2 plus 2ab sine square c by 2 plus b square sine square c by 2. So here if you take these two, this will be a square, and if you take these two, this will be b square, and 2ab, again this cos square, it will be 2a, oh so sorry, minus cos square c minus sine square c, this will be cos c, cos 2c formula, cos square c minus this. So here this is from cosine formula, this is c square is equal to left hand side. So now question number 10, question number 10, question number 10, yeah, you see question number 10. Question number 10, if your a to the power of 4 plus b to the power of 4 plus c to the power of 4 is equal to 2c square a square plus b square, then you have to prove that angle C is equal to 45 degree or 135 degree. So here you see a to the power of 4 plus b to the power of 4 plus c to the power of 4, this is equal to 2 c square a square plus 2 c square b square. So this will be a4 plus b4 plus c4 minus 2c square a square minus 2c square b square minus 2a square b square is equal to 2a square b square. So if you see this, this is plus plus, this is plus. So if you make an arrangement, this will be minus a square uh, uh, minus, so this remains 2, and then minus this, and then minus this, minus b square plus c square, the whole square is equal to 2a square b square. So this I can write as a square plus b square minus c square, the whole square, 2a square b square, taking square root both sides. If you take square root both sides, so this will be a square plus b square minus c square is equal to root 2 ab. So here this will be a square plus b square minus c square, let it be by ab, that is equal to root 2. Now I can do this as a square plus b square minus c square by 2ab is equal to root 2 by 2. So now here this is cos c formula, this will be root 2 means plus minus, so this will be I can write plus minus 1 by root 2. So cos c will be equal to, so your c, from this it is clear that cos 45, your c is either 45 degree or 135 degree. So this is first part of my trigonometry. This is the first part of the trigonometry. In the next video you will get the second part of the trigonometry.